The ArduCrop sensor network, developed by CSIRO's High Resolution Plant Phenomics Center, is a smart wireless sensor network that has the ability to collect high throughput temperature data in real time. The network consists of a number of high precision infrared sensor nodes that work cooperatively with one another and together with a coordinator that wirelessly transfers data directly to a database. This instructional video will assist you with the installation of the sensor network in the field and provide more details on the ArduCrop sensor network. All the equipment and hardware needed to set up the ArduCrop sensor network are shipped to you in a convenient crate. You should take note of how the contents have been packed into the box, but don't worry too much, as instructions for this are included in this video. Inside the box you will find 32 ArduCrop sensor nodes and a coordinator. You will also find all the necessary hardware needed to install the sensor network. This includes a telescopic coordinator pole, which consists of an earth anchor post, 4 earth anchor stakes, a 3-section telescopic pole, and 3 pin clips. The ArduCrop sensors are also mounted on a telescopic pole. Inside the box you will find 32 2-section telescopic poles, 32 star pickets, and 32 pin clips. You also find a 4-pound sledgehammer, a T-handled slide hammer, which you will need at the end of your deployment for removing the earth anchor stakes, and an ArduCrop sensor cleaning kit needed for the ongoing maintenance of the ArduCrop sensors. It is important to note that the sensor nodes in each box are linked explicitly to a single coordinator through a unique PAN ID, or Personal Area Network Identifier. If you are deploying multiple sets of sensor nodes, ensure that all nodes that belong to a coordinator remain with that coordinator. You can identify which nodes belong to which coordinator by the serial numbers found on each device. A coordinator will have a serial number such as FEN1000, and its sensor nodes will be numbered from FEN1001 to FEN1032. It is recommended that only 30 sensors be used at a time, and that the other 2 sensors be kept as spares in case of problems. Before going through the details of installing the sensor network, I would like to go over a few fundamentals of installation. Following these points will decrease the likelihood of interruptions occurring with data collection. Points 1 and 2 are important for the solar charging of the nodes and coordinator. For maximum sun exposure, face all solar panels to the north and avoid shady areas. Line of sight is also important, so avoid barriers in between the nodes and between the nodes and the coordinator. Follow the 50-meter rule. Try to place nodes no further than 50 meters from the coordinator or to another node. Part 1. Setting up the coordinator. For this part, you will need the earth anchor post, the 4 anchoring stakes, and a sledgehammer. You will also need the telescopic pole sections, which consists of 2 long pieces and 1 short piece, and 3 pin clips. And you'll need the coordinator. First, we need to turn on the coordinator. To do this, simply take the lead and connect it to the terminal. Next, we need to install the earth anchor post. This is best done with 2 people. As one person holds the earth anchor post upright, the other should insert the 4 earth anchor stakes and use the sledgehammer to hammer them into the ground. 2 things are important at this stage. The solar panel on the coordinator must be facing north to maximize the exposure to the sun, so orientate the pole in such a way that this is made possible. The second is that the pole is as straight as possible, so feel free to use a spirit level at this point. To ensure proper anchoring, hammer the stakes as far as they will go. For removing the anchoring stakes, a T-handled slide hammer is included. Use the square slot to get it started and the rounded slot for the rest. With 2 hands, slide the weight of the hammer towards your body. To put the telescopic pole together, Fit the sections together, securing them with the pin clips provided. Now put the pieces together. With the coordinator turned on, slide it onto the top of the pole. As one person raises the coordinator and pull, the other will secure it in the earth anchor post with a pin clip. At this point, make sure the solar panel is facing to the north. Part 2. Turning on and installing the ArduCrop sensor nodes. Before putting the sensors out in the field, make sure to power them on first. With an Allen key, remove the screw and then pull out the aluminum block so that we can get to the on-off switch inside. Use your finger or something pointy to switch the unit on. The red light tells us the unit is powered up. Before putting the unit back together, make sure that the O-rings are clean of debris. Check that all the wires are connected properly. And if the desiccant has fallen out, make sure you put that back in the tube as well. Line the holes up, put in the screw, and use the Allen key to tighten. Also, make sure that the gland nut is completely tightened, that the solar panel is clean, and wash your hands afterwards as insecticide has been used on the top of the unit. Each ArduCrop telescopic pole is made from a star picket, 2 pole sections, and a pin clip. The first step is to hammer the star picket into the ground. Using the pole section that has holes in it, insert a pin clip into the bottom hole as shown. Slide this pole into the sleeve of the star picket. The thinner of the 2 poles goes inside the first and sits on top of the pin clip. The ArduCrop sensor slides onto this pole. Switching the pin clip to higher holes allows you to raise the height of the ArduCrop. This allows for a variety of heights up to 2 meters. The height at which the sensor sits above the object to be measured is important. The sensor is fixed at a 45-degree angle and has a fairly narrow field of view of 10 degrees. A sensor height of around 600 millimeters above the object is recommended, as this gives a suitable measurement area. The table and graphics shown here illustrate the relationship between sensor height and the measured object attributes should you wish to make such adjustments. A copy of this can be obtained by contacting the High Resolution Plant Phenomics Center. Part 3. Cleaning the ArduCrop sensor. The included sensor cleaning kit contains cotton buds, compressed air, and isopropyl alcohol. The sensor should be checked regularly and cleaned when required. First, dip the cotton bud into the isopropyl alcohol. Gently insert the cotton bud into the hole and give it a spin to clean the sensor. You can use the dry end of the cotton bud to soak up some of the excess alcohol. Finally, use the compressed air to dry the sensor. Check the sensor for visible dust and marks, and if need be, clean it again. Part 4. Packing up. Before returning the sensors and hardware, please ensure that all the nodes are powered off, as well as turning off the coordinator by disconnecting the lead from the battery terminal. Please also give the hardware a good cleaning, ensuring to remove as much dirt as possible. All the metal hardware and tools go in the smaller of the two sections. The coordinator and 8 sensor nodes go on the bottom layer of the other side. Place the board with a hole over top of the first layer as shown, and then place 12 more nodes on top. Add the other board and then put the other 12 nodes on top of this. Screw the lid back onto the box and then please return to the following address. For any questions, please contact the High Resolution Plant Phenomics Center.